Our world is teeming with life, from the simplest creatures to humankind itself. Now imagine a world bathed in deadly gases, seared by heat waves, or crippled by lethal falls in temperature. A world smashed by asteroids, blasted by superheated shock waves. A killer planet, capable of wiping out 95% of all the creatures that live on it. Sounds like a science fiction nightmare, but it's hard scientific fact. That planet is ours, planet Earth. In the past, mass extinctions have wiped out more species than exist today. And someday, it's going to happen again. "99% of all the animals and plants that ever lived on planet Earth are now extinct. Some were outcompeted by other species, but many died in mysterious wipeouts that decimated life across the globe. What disasters might we face in the future? Naked Science investigates mass extinctions and asks, if another wipeout strikes, what are our chances of survival?
Organisms may be just doing great, and suddenly some chance event comes along and wipes out a large component of life.
What we see is the nearest the Earth has come to losing all life.
If something like this happens again, we may well be one of those species that will disappear.
I think for humans, this would be essentially Armageddon. It would be the end of our species.
Scientists call these wipeouts mass extinction events. On 5 separate occasions, a catastrophe has wiped out many thousands of species in a single stroke. These wipeouts happened millions of years ago. So why should we be worried today? The answer is simple. It could happen again. In fact, it could already be happening. And this time, we could be the cause.
Undoubtedly, we're going through a 6th mass extinction at the moment. We are creating equivalent to a natural catastrophe, but it's entirely man-made.
Could we survive a wipeout? Scientists are piecing together past extinction events. What happens in a wipeout? What does it take to survive? Clues from the past may be our best hope for the future. Our first stop is 65 million years ago. This is the time of some of the most extraordinary creatures that ever lived, the dinosaurs. After ruling the planet for more than 160 million years, they suddenly died. Why? Dino detective Phil Curry is leading the search to find out. Provincial Park, the Canadian Badlands, dinosaur country. Curry comes here to hunt for clues about the death of one of the biggest, baddest dinosaurs of them all.
These bones have a very distinctive shape and a very distinctive texture, and that tells us that this is Tyrannosaurus rex.
The ground is littered with fossils.
We have the top of the leg bone. It really isn't that much bigger than my leg bone. It's a small Tyrannosaurus rex. A full adult can be up to 8 times my length and weigh as much as 6 tons.
T-Rex was the ultimate predator, a killing machine that dominated its environment for 20 million years. Then suddenly, it died out. What happened? Fossil evidence shows the dinosaurs disappeared everywhere and almost instantly. Whatever killed them, it was big and it was deadly.
I'm one of the people who believes that something catastrophic, something really big happened.
Another scientist who's hot on the trail is astronomer Dan Durda. Durda is studying an unusual layer of clay in Trinidad, Colorado. In the rocks below the layer, there are dinosaur fossils. Above it, none. Something wiped them out.
In this clay layer are some materials that one wouldn't ordinarily find. There is a metal, iridium, which is very rare in the crust of the Earth.
The layer contains more than 200 times the normal level of iridium. A clue to how it got there comes from quartz crystals in the clay. They are fractured and shocked.
Those tiny grains show deformations, changes to the crystal structure, which is the evidence of the intense pressures and temperatures.
What has the power to do that to quartz? We can only do it one way. A nuclear explosion. But the dinosaurs died 65 million years before nuclear technology. What natural phenomenon could pack enough punch to shock quartz and produce huge quantities of iridium? The likely answer, an asteroid. Space. 65 million years ago, a lump of rock the size of a mountain. It's 6 miles wide, weighs about 1 trillion tons, and it's on a collision course with Earth.
So picture, if you will, Mount Everest slamming out of the sky on top of you at 40,000 miles per hour.
The asteroid smashes into the coast of what is now the Yucatan Peninsula in Mexico with a force 2 million times more powerful than the biggest nuclear bomb ever detonated. The impact creates a crater 100 miles across. It sets in motion a deadly chain of events.
1,000 miles an hour blast of wind propagated out from the impact site and wiped flat forests for several hundred miles in every direction.
The impact triggers colossal earthquakes. A plume of vaporized rock soars into the stratosphere. Some of it blasts hundreds of miles away before raining back down on Earth. A superheated blast wave roars out at twice the speed of sound. It incinerates everything in its path.
The blast wave, the fireball, and the debris raining back from the impact crater itself would have blown T-Rex flat, burned him to a crisp, and then buried him.
Temperatures rocket upward.
The debris heating the atmosphere to pizza oven temperatures would have wiped out animals and plants even on the other side of the planet.
Fragments from the impact hurtle around the planet. Some make it to Trinidad, Colorado.
This thin white layer of clay is the little bits of Mexico that came to visit Colorado 65 million years ago.
This is a global disaster. Its effects reach from Mexico right around the world. Dust from the impact is thrown into the sky, blocking the sun. The temperature suddenly drops. Plants and animals begin to die in the cold. Suddenly, big predators like T-Rex have nothing to eat. The food chain collapses.
Even at the furthest point from the impact, you were looking at mass starvation setting in.
The asteroid strike changes the face of planet Earth forever. For T-Rex, this is the end of the road. Every last dinosaur is wiped out. What would have happened if dinosaurs like T-Rex had survived?
I think that dinosaurs would have continued to evolve, change, and improve. They probably would have outcompeted us. Perhaps we would be hunted by dinosaurs even.
Are we in danger today? Meteor Crater in Arizona proves impacts do happen. Or Tunguska in Siberia. 100 years ago, a strike flattened at least 800 square miles of forest. Scientists put the chances of a major impact in the next century at 1 in 5,000.
Those sorts of impacts happen very rarely in Earth's history, but that doesn't mean we're completely safe. An event of that scale could happen tomorrow.
Could humanity survive? Generally, species that survived the dinosaur wipeout were the most adaptable. Scavengers who could eat whatever was available. And some birds the living descendants of dinosaurs.
Birds would fly and cover huge distances for the food that they needed to survive. And of course, they were still able to find mates.
They survived, but could we? We're adaptable, but are we adaptable enough?
Human adaptability is actually very good. We can go into outer space or we can go to the bottom of the sea. But the problem is, if the world that we love to live in is totally altered, if all of our food sources perish, we might survive, but we might not like what we survive in.
As a species, humanity may find new ways to survive, but only the lucky few. As our crops fail, many will starve.
But unfortunately, I think with an impact of that magnitude, for humans, this would be essentially Armageddon. It would be the end of our species.
If it happens, the outlook for our species is not good. Wipeout. Not all extinctions are so simple. 250 million years ago, an extinction event wiped out 95% of all species on Earth. It didn't come from outer space. It may have come from deep inside the Earth. An unstoppable process that could threaten our very existence. On 5 separate occasions in our planet's ancient past, a catastrophe has wiped out millions of species in a single stroke. 65 million years ago, an asteroid strike wiped out over half the species on the planet, including the dinosaurs. But the mother of all extinctions happened 250 million years ago. A single event killed 95% of all species. Clues to this catastrophe lie in the Karoo Basin, South Africa, today barren and inhospitable. 300 million years ago, during the Permian era, this was a lush floodplain teeming with life. Kings of the Karoo were the Gorgonopsians, mammal-like reptiles that lived long before dinosaurs. They were killers, successful, ruthless, and quite literally cold-blooded. Then, 250 million years ago, they all vanished. What happened? Why did such successful predators die out? Gorgonopsian expert Roger Smith explains.
The top predators of the late Permian were undoubtedly the Gorgonopsians, and clearly they're armed for the kill. These long saber-like teeth brought the animal down. They were the saber-toothed cats of the late Permian.
Today, the Karoo is a Gorgonopsian graveyard, a paleontologist's paradise. The rocks here hold vital evidence as to what wiped them out. Layers of rocks create a timeline, going back into Earth's ancient past. As Smith tracks through the layers, he comes to a tipping point at the end of the geological period called the Permian. Below this layer are fossils of Gorgonopsian. Above, there are no fossils at all.
These blue-green mud rocks of the Permian represent lush, wet floodplains, lots of life, lots of flourishing vegetation, and many types of mammal-like reptile. This is the point of extinction. Here, over 95% of life on Earth went extinct.
The Permian extinction wiped out nearly all the species on the planet.
Above it, a dead zone, almost completely barren of life.
This is one of the greatest murder mysteries of all time. Genocide on an unimaginable scale. Just 1 in 20 species survived. What could cause such incredible devastation? It perplexed scientists for over 100 years. Then in the 1990s, they made a breakthrough, not in Africa, but thousands of miles away in Siberia. Beneath these frozen wastes, scientists discovered the Siberian traps, thousands and thousands of square miles of lava. No conventional volcano can produce this quantity of lava. Instead, it wells out from cracks or fissures in the Earth's crust. It's called a flood basalt. Enormous pulses of heat rising from the Earth's core cause the rips. Geologists call them mantle plumes. As the hot plume rises through the mantle, it melts vast amounts of rock, which build up below the Earth's crust like a giant mushroom. The pressure is immense. It forces the crust to split open. The lava flow begins. Disaster scientist Bill McGuire believes flood basalts are one of the most powerful forces on the planet.
The Siberian flood basalts were the biggest outpouring of volcanic material for the last 500 million years. And we've seen absolutely nothing like it in the whole history of humankind and our planet.
The Siberian traps continued to erupt for nearly 1 million years, producing up to 1 million cubic miles of lava, a mile deep. One of the largest volcanic explosions humans have ever witnessed was Krakatoa in 1883. It lasted less than a day and threw out just 6 cubic miles of lava, yet over 36,000 people died.
So you need 150,000 Krakatoas to meet the size of the Siberian traps, which is extraordinary.
Is this the smoking gun? Did lava trigger the Permian extinction? The Siberian traps were pumping out lava at the right time. Now scientists are beginning to piece together how a flood basalt in Siberia could become a global killer. Siberia, 251 million years ago. The ground shakes. The Earth's crust rips apart. The largest catastrophe ever to hit the planet begins.
It would be hell on Earth because you would have these huge fractures slashing the crust open. Then you would have very fluid lava fountaining out, pouring off in all directions, more than 1,000 degrees in temperature. So any life around there would be burnt.
Any animal too close dies instantly. But animals died all around the world. What turns the Permian flood basalt from a local disaster into a global wipeout? Smaller, more recent flood basalts may hold the answer. 1783, Laki, Iceland. The ground rips open, spewing out lava. Lava pumps out for almost a year. It covers over 300 square miles. Everything in the immediate vicinity dies. But like the Siberian event, its effects reach much further. Soon much of northern Europe is suffering. At the National Ice Core Laboratories in Denver, Colorado, Jim White studies ice cores drilled from deep within the snow and ice to study what happened at Laki. The ice absorbs and preserves chemicals from the atmosphere. Over thousands of years as snow falls, layers of ice build up to create a unique record of the environment through history. White uses these layers of ancient snow to study atmospheric conditions from the past. By testing the electrical conductivity of the ice layer from the time of the Laki eruption, White discovers a massive surge in atmospheric sulfur. His conclusion? The eruption released huge quantities of sulfur dioxide into the atmosphere.
So you see the original eruption here on Laki, the big one, is quite sizable. Pulse of sulfate here is maybe 10 times higher than the background levels you see before that.
A poisonous haze spreads across northern Europe. Sulfur dioxide reacts with water vapor in the atmosphere to create sulfuric acid. Acid rain falls, killing the plants and eroding the soil.
Imagine if you're a plant, you really don't want to be bathed in sulfuric acid, but that is indeed what happens.
That's just the beginning. Sulfur high in the stratosphere blocks out sunlight. The droplets act like tiny mirrors, reflecting sunlight back into space. Across Europe, temperatures plummet. The Laki flood basalt releases 122 million tons of sulfur into the atmosphere. Crops fail. Famine begins to bite. 50% of the cattle die. 25% of Iceland's population is wiped out. Locke helps scientists explain how flood basalts could cause mass death, toxic gases. But is gas alone enough to wipe out nearly all the species on Earth? White thinks it could be, because the gas coming from the Siberian eruptions was in the trillions of tons.
What we saw on that screen would be dwarfed by what you would see.
Compared to the Siberian event 250 million years earlier, Locke was a walk in the park.
The Lake eruption occurred in southeast Iceland, and it actually covered a relatively small area, about a third the size of Greater London. And that was a devastating event. If we look at the Siberian flood basalts, they covered a huge area that amounts to the whole of the central part of Russia. Something like the size of the United States. That means that the volume of the Siberian flood basalts was something like 250,000 times bigger than the volume of the Lake basalts. That's why they wiped out 95% of all species.
Not only were they bigger, they went on for nearly 1 million years longer. After the sulfur gas, a new crisis hit. Another gas, and another climate change. Lush, fertile land turned to desert. The oceans turned to poison. It was a disaster almost nothing could survive. 250 million years ago, 95% of the species living on Earth vanished. It is one of the greatest murder mysteries of all time. We know that flood basalts in Siberia release sulfur dioxide into the atmosphere, creating deadly acid rain. Temperatures dropped suddenly, causing a savage freeze. Plants and animals perished. But that was just the beginning. Next, the Siberian traps released an even more deadly killer. A killer that triggered a heat wave. The molten rock released huge amounts of another gas into the atmosphere, carbon dioxide. As much as 6 times more carbon dioxide was pumped into the atmosphere as we have today, according to paleontologist Peter Ward.
Carbon dioxide goes up in the atmosphere, doesn't go into space, blankets the planet, and it acts very much like a greenhouse, and that's why we call this a greenhouse gas. It effectively traps heat. Sunshine comes through the blanket one way, but can't get back out again. It's trapped inside. The blanket of heat warmed the entire planet. There's no place to hide, no place to go.
As the Siberian traps continue to erupt, carbon dioxide builds up and up. The heat wave begins. In the Karoo Basin, temperatures suddenly leap 15 degrees. The result, catastrophe.
If it had happened over 1 million years or so, animals and plants would have adapted. But the reason it was so disastrous is it could happen over a very short space of time, perhaps 10,000 years at some estimates.
The rock layers reveal the exact time when the sudden heat increase turned this lush plain into a desert.
The bluish-grey mud rocks of the Permian represent wet floodplains, a time when the water tables were very high, there's lush vegetation.
As the Earth heats up, more of the planet's water evaporates. Rivers dry out. Iron-bearing rocks, normally underwater, turn rust red as they react with oxygen in the air.
In short, it's the first time we see drought in the Karoo Basin.
Vegetation withers and dies. Plant-eating animals begin to starve and die out. As the plant eaters vanish, predators like Gorgonopsian lose their prey. They too start to die. The wipeout has begun. The land is dying, but life is not safe even in the oceans. Marine life too is under pressure. Geologist Paul Wignall discovered vital clues about the marine wipeout when he traveled to Greenland in the 1990s. He found an extraordinary record of mass extinction.
We really lose virtually everything that was in the oceans at the time. We've wiped out about 95% of the species, and the oceans are pretty empty now.
What killed them? The rocks here tell a story. The creatures may have suffocated from lack of oxygen.
What we found in the sediments is lots of crystals of a mineral like this is pyrite, which is also known as fool's gold. It cannot form in the presence of oxygen. It just hates oxygen.
If pyrite crystals could form in the sea, then there wasn't much oxygen. Normally, oxygen dissolves into seawater at the surface. Currents that circulate between the equator and the poles then carry the oxygen with them. Because there is more sunlight at the equator, the sea here is warmer. As this warm water moves toward the poles, it cools and sinks, carrying that dissolved oxygen down into deep water. The oxygen-rich water then runs back toward the equator along the ocean floor, and the cycle continues. 250 million years ago, in the aftermath of the massive volcanic explosions in Siberia, that mechanism fails. The same heat that has dried out the floodplains now warms the oceans, even at the poles.
I'm sure the oceans around the equator may have reached temperatures approaching 100 degrees Fahrenheit, real warm sort of bathwater temperatures near the poles and so on. You're looking at temperatures more akin to California today.
With no cold water at the poles, the ocean's circulation system shuts down. Oxygen no longer mixes down into the water. Sea creatures start to die off. First the land, then the seas. The Siberian flood basalts affect everything. They leave the oceans almost entirely dead. But scientists aren't convinced that heat alone could wipe out as much as 95% of life on land. For that, they need another explanation, another smoking gun. They now believe that at the end of the Permian era, conditions are just right for one last killer, the most deadly of them all. It's a killer that's still with us today. All you need is a swamp.
Ooh, that smell is a horrible rotten egg smell. It comes from the bacteria in the sediment. They produce hydrogen sulfide gas, which is a very toxic gas. They do so only in conditions of low or no oxygen, such as the swamp.
In the low oxygen conditions of the Permian period, these bacteria do more than just smell. In larger quantities, the gases they produce kill.
If the Earth had low oxygen everywhere, and the small amount of hydrogen sulfide would be multiplied immensely to the point that it would be dangerous for life on the planet.
We know sulfur-producing bacteria flourished during the Permian extinction. Their fossils are there in the rocks in quantity. Their presence suggests that by the end of the Permian period, the air itself was deadly.
And you have a new type of kill mechanism. And this is the evidence that, to me, has, I think, solved the whole mystery.
The sulfur gases may have delivered the final blow, even to the hardy Gorgonopsians.
So if our poor Gorgonopsian is in a case with low water, low oxygen, plus it's harder to find food, and now hydrogen sulfide is coming out, well, you've got a weakened animal, much more susceptible to dying off. And then finally comes a year where one poor last female is looking for the male that isn't there, or vice versa, and then they're extinct.
Wipeout. It's happened once. Could it happen again? This time to us? Flood basalts strike on average every 20 million years. Really big ones, like the Siberian traps, are rarer still. But they do happen. At some point in the future, it will happen again.
There's nothing we could do about it. We'd have to stand back and be awed and amazed, and it would be rather depressing as well.
If the worst does happen, humanity may not survive.
That the Siberian flood basalts constituted the greatest mass extinction ever seen on our planet. And if something like this happens again, we may well be one of those species that will disappear.
In terms of sustaining a complex civilization, that would be the last thing on people's minds. The simple fact of existing would be trouble.
Just how would we survive as a species? Very few Permian creatures survived beyond the extinction line, and those that did were the most adaptable. One, the Lystrosaurus, evolved a long, sturdy snout handy for chopping through the few hardy drought-resistant plants that were still around. Other species made it through by living underground. Could we survive the same way? Most scientists are unsure.
Surviving underground for hundreds of thousands or millions of years is just not going to happen. We don't have any technology that would be able to cope with this sort of thing at all.
So when it comes to the crunch, it's going to be those humans that are better adapted to living underground, low oxygen conditions. They will be the ones that will survive. It'll be survival of the fittest again.
Even the best may not be good enough. The planet above those few hardy cave dwellers would be wrecked. Hardly any vegetation, almost no life at all. If the Earth is hit again by a Siberian-scale flood basalt, our chances of survival are slim. Wipeout, strike two. Not all mass extinctions are caused by asteroids or volcanic lava. Some may be triggered by a sudden blinding flash of light from exploding stars. A burst so powerful that it may have caused the second largest wipeout in Earth's history, and could happen again. We're the top species on Earth, but that's no guarantee of survival. Look back 440 million years. The dominant species is the trilobite, a crab-like creature that has already ruled the seas for 100 million years. Now they are dying out, along with 70% of all the species alive. It's the second largest wipeout in Earth's history, the late Ordovician. Unlocking the secrets of their demise is paleontologist Bruce Lieberman.
If an alien from outer space was visiting, it would probably characterize life on Earth as dominated by trilobites. Most of them were probably scavengers. There may have been a few forms that were predatory on things like worms.
Scientists originally thought that a global ice age had caused the wipeout. There was evidence of ancient ice deposits in the Sahara Desert. But Lieberman isn't convinced it could have killed so many species.
We have had other glaciations in the geological past that do not produce mass extinctions on the scale that we see at the end of the Ordovician. So that's why we can't treat it as a smoking gun.
By chance, Lieberman was invited to a discussion held by astrobiologist Adrian Malott, who had an idea he wanted to explore. Malott studies gamma-ray bursts, the most powerful explosions in the universe. NASA's SWIFT satellite, launched in 2004, detects on average a gamma-ray burst a day. Scientists don't know what causes all gamma-ray bursts, but they do know that the worst and most deadly for Earth come from giant exploding stars called supernovas.
A small fraction of those would be on our side of the galaxy and would have the beams pointed at us. If that happens, we have a recipe for disaster. The effects are so severe that you naturally think of mass extinctions.
Malott was sure that one must have hit the Earth in the past, but he didn't know when. He asked Lieberman if there was a mass extinction that might fit with his ideas.
When Adrian Malott described what would happen if a gamma-ray burst was sufficiently near our planet, I literally had an aha moment.
Professor Lieberman said that sounds like the Ordovician extinction, and we thought we had a connection.
The two scientists needed to reconstruct what would have happened if a gamma-ray burst had hit in the time of the trilobites. Space, 440 million years ago. A supernova explodes. It's within 10,000 light years from Earth, but that's close enough to be deadly. A massive burst of gamma rays heads toward our planet. First to suffer is the atmosphere. The gamma rays change the chemistry of the air itself. The huge blast of energy rips apart nitrogen and oxygen molecules, enveloping the Earth in smog, including the deadly gas nitrogen dioxide.
The very dangerous genie in this bottle is nitrogen dioxide, normally present in the atmosphere in very small amounts. If I were to open this bottle, we'd all be choking and gasping. In the aftermath of a gamma-ray burst, the whole atmosphere of the Earth would contain large amounts of this.
This smog blocks out sunlight and sends temperatures plummeting. possibly even triggering an ice age. But there's another more devastating effect. The initial gamma ray burst and the growing cloud of nitrous oxides destroy the ozone layer, the very thing that shields Earth from the sun's lethal ultraviolet radiation.
Many plants and animals would die. It might even be sufficiently severe to cause a mass extinction.
The sun itself becomes an agent of death. 5 times the normal amount of UV radiation hits the Earth. It damages the DNA of almost every plant or animal it hits. The smog acts like a sieve. It allows UV light, which has a short wavelength, through, just like a sieve allows flour through. But it blocks the longer wavelength light that provides us with heat. In this demonstration, the sugar, which unlike the flour, doesn't get through the sieve. Without the heat from the sun, temperatures sink to a deadly low. A single gamma ray burst, just a few seconds long, could trigger an ice age and damage the DNA of almost every living thing. It was the breakthrough Lieberman had been looking for.
That, in effect, is the 1-2 punch that may have caused this mass extinction.
UV radiation can only penetrate a certain distance through water. The deeper an animal lived in the ocean, the more likely it would survive. And that's what Lieberman found. The young of some trilobite species stuck close to their families on the ocean bed.
These guys are the lucky ones. They didn't know that this mass extinction was coming, but they were shielded from the ultraviolet radiation.
Babies of other species swam close to the surface,
which makes them far more susceptible to the effects of a gamma ray burst. In particular, the increase in the ultraviolet radiation would mean that the baby or juvenile form would be far more likely to be zapped.
Lieberman had finally found a likely suspect for the trilobite extinction.
To find something that could potentially be responsible was extremely exciting.
The mystery of what could have killed 70% of all life in the oceans was solved. Wipeout. So what are the chances that we'll follow the trilobites into oblivion? We think there isn't a star close enough to cause damage at the moment. But if a burst hit, we'd be in trouble. Gamma rays travel at the speed of light, the fastest thing in the universe. There would be no warning. The first we'd know would be a blinding flash of light.
If you were looking at the sky, you might well be blinded by such an event.
The pulse would be over in seconds. Within hours, a cloud of smog would engulf the planet. The immediate danger would be sunburn and skin cancers. Then the DNA damage would begin. Adrian Malott has calculated that it could take years before it was safe to go back outside.
Even after 4 years, the level of DNA damage is still higher than it was before the burst went off. And it'll take 10 years to get essentially back to normal.
Humans might survive by staying indoors, but plants and wildlife would be devastated.
Billions of people would have starved to death because many plants and animals would die.
I think the human species would survive, but the amount of population that could be supported would be perhaps 5 to 10% of the population on the planet today.
So it would be a full-scale worldwide disaster.
A gamma ray burst also delivers an electromagnetic pulse. It would fry anything that relies on electronics. Our entire infrastructure would collapse.
Many of us would be living in the 19th century again.
This disaster wouldn't last as long as a flood basalt. It wouldn't be Armageddon like an asteroid impact. A gamma ray burst would affect us maybe for a decade. Billions would die. But this is one wipeout we might just survive. Gamma ray bursts are incredibly rare. Mass extinctions are rarer still. Chances are we're safe, right? Wrong. Scientists say we are in the middle of a mass extinction right now. Could our own date with destiny be just around the corner? In the last 440 million years, there have been 5 major mass extinctions on planet Earth, and several smaller ones. Together, they have wiped out vast numbers of creatures that have ever lived. What's worrying is scientists have noticed a pattern, not in the causes of extinctions, but in timing. Give or take, they hit every 62 million years. Astrobiologist Adrian Malott believes the trigger may not be on Earth. It could be in space.
Well, obsessing about this for a long time, it's a tantalizing hint because a long cycle like 62 million years sounds like something associated with a galaxy.
Malott has joined forces with fellow astrophysicist Misha Medvedev. They suggest a new prime suspect for triggering extinctions: the way we move through space. Our galaxy travels through space at 125 miles per second. When it hits a gas cloud, it creates a massive shock wave. Just like a plane breaking the sound barrier.
It's exactly the same with the galaxy. When the galaxy moves through gas in the outer space, it creates a shock wave around it.
These shock waves accelerate atoms of charged gas, creating high-intensity cosmic rays, capable of creating cancers and mutations. This intense lethal radiation then rains down on our galaxy and eventually Earth. Normally, our galaxy and our planet are protected from cosmic rays by the galaxy's magnetic field. But our solar system moves up and down within the galaxy. When we're deep inside, we're protected. When we move up from the thick central disk, we're exposed. Imagine a diver deep in the ocean. It's pitch black, no light gets through. As she rises to the surface, she's exposed to more and more light.
And when the solar system and the planets go close to the surface of a galaxy, it's like being close to the surface of an ocean. They are more exposed.
Medvedev has calculated that this increased exposure happens between every 62 to 64 million years. That's when extinctions happen. Only one event doesn't quite fit the pattern: the asteroid strike that wiped out the dinosaurs. If the galaxy theory's right, does that mean the flood basalt and gamma ray burst theories are wrong? Not according to Malott. He says the cosmic rays periodically weaken life on Earth. When the other catastrophes hit, organisms are less able to survive.
It's like being shot when you have the flu. You're much less likely to survive.
According to the theory, Earth will get cosmic flu again in 10 million years. But will humans be around to experience it, or will we have destroyed our world before then? In the Permian extinction, volcanic eruptions started a chain reaction. Carbon dioxide swamped the atmosphere. Temperatures rose by 15 degrees. It killed 95% of all the species on Earth. Sound familiar? It should. In the last century, we have more than doubled the amount of carbon dioxide in the atmosphere, and it's still rising. The next wipeout could be entirely our fault.
It is a warning from history, the fact that this sort of rate of increase and the levels that are being attained has happened before, and it was bad before, and if we're not careful, it'll be bad again.
Well, I'm very worried that we are heading down a very nasty path. If there is a chance that we could head to another big mass extinction because of what we're doing to the climate, then we have to do everything in our power to stop it.
At present, no one knows if man-made climate change will cause a global wipeout. But we certainly have the power to make life on Earth as tough as it was during the Permian extinction. Our world could become uninhabitable, our survival a question of luck. Beyond even that threat lies another. If we survive asteroid hits, gamma ray bursts, and the effects of our own success. In the long run, the sun will make life on Earth impossible. It will expand and melt the surface of our planet. Humans will only survive if we change our address. After that, billions of years from now, the universe could rip apart, and that would be the end of everything. No life, nothing. One day it will all be over. The question is, How long have we got?